Okay, so when we're adding and subtracting fractions, you have to have common denominators. When you're multiplying, you don't. So we have rational expressions, so it's no longer going to be like 1/2 and 2/3 and stuff like that. You're going to have actual expressions like this that you're trying to add. So you still need to have that same concept of I need like denominators, okay? So if I have already like denominators, okay? So just an example, if I have 1/2 plus 3/2, I could add those because they both have a denominator of 2, and that would become 4/2, which is 2. Okay, so I can do that because of my denominators, and then I just add my numerators. So the same concept, that denominator does not change. Okay, I don't add 2 plus 2 to give me 4 for the denominator. So when I have 9x cubed over x plus 1 plus x squared over x plus 1, I'm going to look, are those common denominators? Yes, they're the exact same expression in both fractions. So that means I can add those, and that x plus 1 just stays in the denominator. Okay, and then I just add my numerator. So I'm going to have 9x cubed plus x squared. Okay, now what you need to check for is you need to check for two things. Is it in standard form, and is it simplified? Okay, so when I say is it simplified, you're going to always have to check, can you factor a GCF or can you factor it as in a trinomial? So if I have 9x cubed plus x squared, I could take out x squared as my GCF, and that would leave me with 9x plus 1 over my x plus 1. Okay? I can't do anything. What I'm trying to do is see if I can cancel anything out. I can't cancel anything out, so that's my answer. Okay? But you need to always check, so you need to always simplify and factor in case you can cancel something out. Okay? So like denominators is not hard. If I have 2 over 3x squared plus 1 over 3x squared, those are like denominators, so 3x squared is my denominator for my answer, and then 2 plus 1 is 3. Okay, well, if I simplify it, that 3 over 3 cancels to 1. 3 divided by 3 is 1, so really I just have 1 over x squared. Okay. And then so if I have 2x squared over x squared plus 1 plus 2 over x squared plus 1, my bottom stays x squared plus 1. And then my numerator, 2x squared plus 2, that's just going to be straightforward, 2x squared plus 2. Okay? And then I need to look, can I factor that numerator? Well, I have a 2 and a 2, so I can take out 2 as my GCF, and that leaves me with x squared plus 1 over x squared plus 1. So by taking out my 2 as my GCF, I have x squared plus 1, x squared plus 1. I can cancel that out, and I'm just left with a 2. Okay, are we okay with that? That's the easy part, like denominators. Okay, so what happens when you have unlike denominators? Okay, so what you're going to need to do is find your least common denominator, your LCD. Okay, if I had something like 1/2 plus 3/5, okay, what would I need to do? What denominator would I need to be able to add these? I would need a 10. That would be my LCD. Okay? 2 and 5, they multiply together to give me 10. So that's going to be my least common denominator. Alright, so in order for me to get them to be 10, I need to multiply 1/2 times what? 5 over 5. And then I need to multiply 3/5 times 2 over 2. You're multiplying it by what it's missing to get it that 10. Okay, so that becomes 5/10, and that becomes 6/10, all to give me 11/10. Okay, so that 10 was my least common denominator. Y'all can do it when you have just basic fractions like this, right? Okay, what if I had 2 over x plus 1 over x squared? Okay, my least common denominator, it says for my variables, I want my highest exponent. Okay, so with GCF, you want your lowest exponent. But with your least common denominator, you want your highest exponent. So my LCD here would be x squared. Okay? So if I need it to be x squared and x squared, I don't have to change that second fraction, right? It's already x squared is what I need. Okay, but this first fraction, I just have an x. So what do I need to multiply it by? What is it missing? Another x. Because x times x will give me that x squared, right? So then that numerator, x times 2, is just 2x. Y'all follow me on that? Okay. So then that would just be 2x plus 1 over x squared. Okay, so those are the more simple examples, just so you can grasp what you're trying to do for your denominators. Okay? So, again, finding your LCD, your numbers, you want the highest common factor. So 2 and 5 would give me 10. Okay. Your variables, you want the highest exponent, and you can manipulate the lower one and multiply it to get to the higher. Okay. Common factors, you're going to write only once. So that means if I factor it and I have a full expression, we'll talk about that in the second example. Okay. So this first example, I have x minus y over 4x minus 2x plus y over 2x squared. Okay, so I'm going to look at my numbers first. So if I have a 4 and a 2, my LCD would be what? 4. Okay. I have an x and an x squared. So I need that to be what? X squared. So 4x squared would be my LCD. Okay, now this just says find the LCD. We're just getting in the habit of identifying what the LCD is. We're not actually doing the operation yet. Okay? So here, on this next example, I have x minus 1 over x squared minus 2x minus 8 minus 2x plus 3 over x squared minus 6x plus 8. Okay, what I'm going to have to do is I'm going to have to factor these denominators. Okay? I'm just going to factor it underneath. If you need the space to the side, then write it out to the side. If I have x squared minus 2x minus 8, that means that 8 is telling me I have different signs, right? If this last number is negative, I have different signs. So that means they're going to subtract to give me the 2. So factors of 8, remember, are 1 and 8, 2 and 4. So the 2 and 4 would give me the 2. I need a negative 2. So that means the 4 is negative, the 2 is positive. Okay, you should hopefully remember these factoring rules. Yes? Okay. And then x squared minus 6x plus 8. Now it's a plus 8. So that means they're the same sign. They're both going to be negative. And there, again, is my 2 and 4 to give me 6. Okay? So what I need to look at is what appears in both. Okay? See how you have x minus 4 in both? That's good. Okay? You only have to write it once. That's what this common factors write only once is talking about. If it appears only once in both terms, then that means that's part of my LCD. Okay? Now, if it would have been x minus 4 twice, then you would have to consider it twice. But it's only showing once. Okay? And then I've got this x plus 2, and then I have the x minus 2. I need all of that to appear for an LCD. Okay? So whatever shows up in both, I'm going to write it here. And then whatever my other factors are, those have to be a part of my LCD. Okay? To me, I think once you factor it, this is the easiest LCD to find because it's just pulling your factors down. Okay? Do you have questions on this? Okay. Alright, so if we look at the next example, we've got 4x plus 5 over 5x cubed minus 2x squared minus 10x plus 3y over 5x squared plus 3x minus 2. So I'm going to have to factor again. Okay? So if I look at my denominator, I have a 5 and a 2. I can't do anything with that. But I have an x cubed and an x squared. So I can take out my x squared as my GCF. So if I take out an x squared, what does that leave me with? 5x minus 2. Right? Y'all remember how to take out GCF? Okay. Alright, then 5x squared plus 3x minus 2. I'm going to write that over to the side because you have a coefficient in front of your x squared. Between 5, 3, and 2, I don't have a GCF. So remember that when you have a coefficient, that's when you multiply first times last. So that's going to give me a 10. Factors of 10 are 1 and 10, 2 and 5. What am I going to choose to give me 3? 2 and 5. Alright, now they're different signs. My larger sign is going to be the positive, the 2 is going to be negative. But I'm not going to just put x minus 2, x plus 5. I have to do what first? Divide it by that a. Remember, you multiplied it, you got to divide it back out. So I'm going to divide both of these by 5. Negative 2 over 5 doesn't simplify. 5 over 5 simplifies to 1 over 1. So this becomes the 5x minus 2 times x plus 1. If you don't remember your factoring, go back to chapter 4. Pretty sure that's when we did factoring because we did quadratics with chapter 4. Okay, so now I need to look at what will my LCD be. Okay, well I know that I have an x squared here, so I'm going to have that part of my LCD. This 5x minus 2 appears in both, only once in both. That's still part of my LCD. And then I need that x plus 1. We good with that? Okay. So now I've got 4 over 5x minus 5 minus 3x minus 4 over 6x minus 6. I need to factor out a GCF for these denominators. Okay, so here I can factor out a 5, and that leaves me with x minus 1. And then the second denominator, I can factor out what? A 6, and that leaves me with x minus 1 also. Okay? So I have to think about this. I know for sure what's going to be part of my LCD. This x minus 1. But now I have to consider between 5 and 6, what's going to be my LCD. So when I had 2 and 5, my LCD was 10. So between 5 and 6, what's my LCD going to be? 30. Remember, it's your greatest common multiple, basically. Okay? We're good with that? Okay. So now we're going to put that into our actual operation. Okay, so what we're going to do is we're going to always try to factor first. We're going to find our LCD, and then we're going to manipulate these two expressions to make sure I have the common denominators. Okay, so if I have 7 over 9x squared plus x over 3x squared plus 3x, I can't do anything with this first fraction, but I can factor this denominator for my second fraction. So I could take out what as my GCF? 3x. Okay, and that would leave me with x plus 1. Okay, so my denominators, I've got a 9x squared and a 3x, x plus 1. So my LCD, I know I'm going to have x plus 1. Okay. Between 3 and 9, what's going to be, what do I need? Could I manipulate the 3 to become a 9? Yeah, so I need a 9. Between x squared and x, you take the highest exponent. So that would be x squared. Okay? We good with that? Alright, so this is what I need my bottom of the fractions for both of them to become. Alright? So what I'm going to do for the first few examples, I'm going to write this out again. But we're going to look at what we need to multiply it by. Okay? So when you're multiplying it, okay, think back to when we did our 1/2 and 3/5. Okay, I'm going to flip it back real quick. When we did this, you took the 1/2 and you multiplied it by 5 because that's the factor you were missing to get to 10, right? And then for 5, I multiplied by 2 because that's what I was missing to get to 10. So I think about what am I missing from my LCD to get this. So if I needed 9x squared times x plus 1, and I only have a 9x squared, what am I missing? The x plus 1. That's what I multiply by. So I'm going to multiply by x plus 1 and x plus 1. It's always the same numerator and denominator. Okay? Now, if I have 3x and x plus 1, I've got the x plus 1, so I don't have to worry about that. What do I need to multiply, or what am I, to get a 9x squared? 3x, right? 3 times 3 will give me that 9, and then x times x will give me that x squared. Okay? So if you see it as what am I missing, then it makes it a little bit easier, at least in my head it does. Alright, so what we're going to do is those denominators just become 9x squared times x plus 1. Okay, that was our whole goal. The numerator, this 7, I'm multiplying by the entire x plus 1. So I'm going to take that 7 and distribute it. So it becomes 7x plus 7. Y'all follow me? And then I take x times 3x, and that becomes 3x squared. We good with that? Okay, so now what we need to do, we need to make it all one fraction, and we need to make sure it's in standard form. So remember, standard form is your highest exponent down to your constant. Okay? So this full denominator is just going to be 9x squared times x plus 1. Okay? And then I'm going to have 3x squared plus my 7x plus 7. We good getting this answer? Okay. Here, once you get here, you would check to factor. Okay. If I tried to factor it, I'd have to multiply 3 and 7, and that would give me 21. Factors of 21 are 1 and 21, 3 and 7. Neither of those would give me a 7. So I can't do anything with that. There's my answer. Yes? The quadratic formula, that's when you're solving. So that's when you want a specific x value. So here, if you can't factor it, you just stop. Okay? We good with that? Okay. So this next one, I've got 3 over 10x squared plus 2x over 5x squared minus 10x. So I'm going to try to factor out something for my second denominator, and I could factor out a 5x, and that would leave me with x minus 2. Okay, so for my LCD, which you have to state your LCD every single problem, okay? For my LCD, I know I'm going to have x minus 2. Okay, then I'm looking at 10 and 5. What do I need? The 10. X squared and x. I need the x squared. So 10x squared, x minus 2 is what I'm missing. Alright, so that 3 over 10x squared plus 2x over 5x times x minus 2. Okay. If I look at my first fraction, I have 10x squared. What am I missing? The x minus 2. So I'm going to multiply by x minus 2 over x minus 2. And then 5x times x minus 2 compared to 10x squared x minus 2. What am I missing? What do I need to multiply by? 2x. Are we okay with that? Do we know how to find what to multiply by? Okay. So then the denominators become 10x squared times x minus 2. So my numerator, I'm multiplying 3 times x minus 2. So I distribute that and it becomes 3x minus 6. And then 2x times 2x becomes 4x squared. Okay, so then I'm going to rewrite it all over the same denominator. And I'm going to put the numerator in standard form. So I'm going to have 4x squared plus 3x minus 6. Okay, then I'm going to try to factor again. So 4 times 6 would give me a 24. So 1 and 24, 2 and 12, 3 and 8, 4 and 6. Would any of those give me a 3? No. So I can't factor it. There is, bless you, my answer. Are we okay so far? Do you have questions? Okay, you want to try the next one? See if you got it before we move on. Try it even if you don't want to. Just try to get your LCD. At least just get that. So can you factor the first denominator? What can I take out? And that leaves me with? Okay. X squared minus 4x plus 3 leaves me with what? You want factors of 3 to give me 4. So x minus 1 and x minus 3. Okay, so for my LCD, what's your full LCD? 2, x minus 1, x minus 3. Did we get it right? Are we okay? Alright, so now I've got my x plus 2 over 2x minus 1 minus my negative 2x minus 1 over x minus 1, x minus 3. Okay? When I look at this denominator and I compare it to my LCD, what am I missing? X minus 3. Okay? When I look at this denominator and I look at this LCD, what am I missing? Alright. So my denominators consist of my LCD okay, my numerator, I've got x minus 3 times x plus 2. I'm going to have to FOIL that. Okay, so x times x would give me x squared. X times 2 would give me 2x minus 3x minus 6. Okay? And then when I'm taking this 2, I'm distributing it to both of those terms. So that gives me a negative 4x minus 2. And don't forget this is a minus in front. Okay? So what I need to do is put it all over the same denominator and combine my numerators. Okay, well this is x squared. 2x minus 3x is going to give me what? Negative x minus 6. Then I'm subtracting this entire negative 4x minus 2. You have to be careful here. Okay? I'm subtracting it, so I'm distributing this negative. So both of those terms become positive. So it's now a plus 4x plus 2. Okay, so I combined my x's for this, and then I distributed my negative to get the 4x and 2. Now I need to just clean it up. Okay, so I've got my denominator. Okay, I have my x squared. Negative x plus 4x is going to give me what? 3x. And then negative 6 plus 2, negative 4. Then I need to check to do what? Factor. Okay? Can I take factors of 4 to give me a 3? Yes. Okay? So my factors of 4, 1 and 4, 2 and 2. So I know my denominator, x minus 1, x minus 3 with my 2 in front. My numerator factors into what? I need a plus 3, so this 1 and 4 combination will give me my 3. I need a plus 4 and a minus 1. Okay? Can I do anything else? I can take out my x minus 1. I've got x minus 1 in the top and the bottom. So that's going to leave me with x plus 4 over 2 times x minus 3. Okay? It's a lot, but this is part 1. Okay? Yes, ma'am. So I could factor out a 2 as my GCF. And so it became 2 times x minus 1. So because a 2 is here, it's got to be part of my LCD. Okay, what other questions do we have? Yes. So say that this would have been like a 6. Then this would have been the 6 because you can multiply 2 by whatever it is. But if this would have been a 5, 2 and 5 would have given me 10. Okay, so it kind of just depends on what you're given. Does that help? Okay. Okay, any other questions? Alright, so that's part 1. We're going to move to part 2. Since we're doing it together, I don't really think it's necessary to do these 2 unless you want to do another one on your own to see if you got it before we move on. Do you want to do that? You want to just move along? Move along? Okay. If you feel like you need the extra practice, you can always go do it later and check the copy of notes that's on the Google Slides. Okay. Complex fractions. Okay, that's what part 2 is going to consist of. Complex fractions means you got a fraction over a fraction. Okay? So, we're not going to do these for time's sake. We're just going to look at what to do. You still have to find an LCD. Okay? But now, I've got 2x over 3 minus x over 4 all over 4x over 2 plus 2 over 5. Okay? You can do this 2 ways. The notes say to do it separately. I don't do it separately because it's less work. It's less work to not do it separately. Okay? I don't want to take the numerator, take the denominator, find separate LCDs, and put it back together and then simplify it in. That's too much. Okay? So we're going to look at all of the denominators. I've got a 3, a 4, a 2, and a 5. Okay? So 3, 4, 2, 5. I need to find an LCD between those numbers. So, sometimes it's really easy, sometimes it takes a little bit of process. Any factors of 5 are going to end in 0 and 5, right? Y'all should know that. Okay? So, think about that and what will 3 and 4 go into? So, if I need a 2 and a 5, I know it needs to end in what? A 0. A 2 will never go into something that ends in a 5. So I'm looking at 10, 20, 30, 40, 50, 60, that. Okay? 10, 3 and 4 won't go into. 20, 3 won't go into. 30, 4 won't go into. Y'all see what I'm doing? 40, 3 won't go into. 50, these won't go into. But 60, I can get all of those. Okay, so my LCD, that's all we're finding. LCD is just going to be 60. So again, we're just looking at LCD right now. Okay? When I have something like this second example, okay, I've got x minus x over 4 and x plus x over 3. I'm only looking at my denominators, which are a 4 and a 3. What would my LCD be for 4 and 3? 12. Okay? Now I have x minus x over 4 over x plus 2 over x. I've got a 4 and I've got an x. What's my LCD? 4x. Okay, when you have a number and just a variable, you just put them together. Okay? Alright, now I have an x, a 1, an x, and a 5. So when I think about my LCD, I'm going to look at my numbers. 1 and 5. 5. I have an x and I have an x, so that's just going to be x. Okay? We good with that? Say that again. Oh, because you're just looking at, so what I did in part 1 was I was showing them, so this rule right here, when you have your variables, you only want the highest exponent with the variables, you're not adding them, you're just finding what is a factor in both, okay, because you're trying to get common denominators. Okay, so again, your instructions in the notes say to do it separately. I think y'all are going to appreciate doing less work. So it's going to take a little bit to visualize, but it's less work. It's easier, in my opinion, to do it the way I'm about to show y'all, okay? So if I'm looking, I've got x over 2 over x plus 6 over x. Look at your denominator, okay? Sometimes it works out this way. My two denominators here are the same. I could simplify this denominator, right? So this could really be x over, I know it'd be over x. What's 2 plus 6? 8. So this really simplifies, and I don't have to do all this extra work. So check to see if it works out. Most of the time it will not, but you just have that small percent chance. When you divide, so if I had 1/2 divided by 3/4, okay? Remember that keep, change, flip that you learned forever ago? Keep, change, flip? Isn't that? Okay. Alright. I know I'm not crazy. Alright, so I would keep the 1/2, change the division to multiplication, and I would flip 3/4 to 4/3, right? You're multiplying by the reciprocal, and then you would simplify from there. I'm not going to do it, but you get what I'm trying to tell you. That is what you're doing with complex fractions, okay? After you get your LCD, which we didn't have to do that for here, but this, I'm going to multiply by the reciprocal. So I take my x, and I'm going to multiply. I'm going to reciprocate. I'm going to flip that 8 over x to become x over 8. Well, what's x times x? X squared over 8. There's my answer. Okay? I didn't have to do an LCD or anything because they were common denominators. No other problem is going to be like that. Okay? So, this next example, I have x squared over 3/2 minus 6 over x. So I'm going to look at my denominators. 2 and x. That means my LCD is going to be what? 2x. Okay? So what I do is I multiply this entire thing by 2x over 2x. Okay? For my numerator, okay, I'm going to cover this up. X squared times 2x, what is that going to give me? 2x cubed. Okay, my denominator. I've got two terms here, right? So what I'm doing is I'm multiplying both of these by my 2x. If you need to write it over to the side, you can, so you can visualize it. Okay, so what I need to do is I need to treat them in my head separately as what is canceling out here. If I'm multiplying by 2x, but I'm also dividing by 2, these 2's cancel, and I'm just left with 3 times x, which is 3x. Okay, and I do the same thing here. I'm multiplying by 2x, but I have an x, so those x's cancel, and I'm left with negative 6 times 2, which is so you're multiplying the whole thing together, and you're seeing what's going to cancel those denominators out. Right? Because think about this. 1/2 times 4/3. What would cancel here? This would become a 2, and this would become a 1, and this would give me 2/3. So when you're multiplying by something and you have a denominator, you should cancel those out And you shouldn't have another improper fraction. The whole reason we're multiplying by this is to get rid of the fraction within a fraction. Okay? Then you check to see if you can simplify. I can't simplify this. I could factor out a 3 if I wanted to, but that's not going to be able to simplify anything. Okay, if I factored out a 3 GCF, it would leave me with x minus 4. That 2 and 3 can't do anything. I'm good with either one. Okay, if you want to just always check to get it into factored form so you don't miss anything, you can. Okay. Let's look at the next one. I've got 3 over x plus 5 over 2 over x minus 3 plus 1 over x plus 5. Looking at my denominators, and I need to come up with an LCD. I have an x plus 5 twice. Do I write it twice or only once? Only once. And what else do I need? X minus 3. So that's my LCD. And that's what I'm going to multiply by. X plus 5 times x minus 3 over x plus 5 times x minus 3. Okay? So when I look at my numerator only, what's going to cancel? The x plus 5. So that leaves me with 3 times x minus 3. Yes? Y'all follow that? Okay. Now my numerator, I've got 2 different terms because I have a plus, right? If you need to visualize and write it over to the left, you can. I don't have space. I'm not going to. I'm just going to think about it. I have x minus 3 here. So for this first fraction, I'm going to take 2 and multiply it by what? What am I missing? If I have x minus 3, but the x plus 5. Okay. Plus, and now I'm going to have this 1. I need to know what am I multiplying that 1 by. So if I'm doing this 1, the x plus 5 and x plus 5 should cancel, yes? So I'm multiplying the 1 by x minus 3. You're just multiplying by what it's missing. Okay? If you keep thinking, what am I missing? To me, it makes it a whole lot easier. Okay? So then 3 times x minus 3. If I wanted to, I could make that 3x minus 9. And then this 2 times x plus 5 becomes 2x plus 10. Plus 1 times x minus 3 is just x minus 3. So 3x minus 9 over 2x plus x is 3x. 10 minus 3 is 7. I can't simplify that. I could factor out that 3 and then just end up with 3x minus 3, but that doesn't do anything. So that's my answer. Do we follow what I'm doing for the most part? What are our questions? Okay. All right, so this next one, I want you to tell me my LCD. Very good. X times x plus 4. Okay, so I'm going to multiply. When I do that with my numerator, what's going to cancel? So I take 5 and multiply it by x, and that's just 5x. It's missing the x. Yes? Okay. All right. Now this first fraction, 1 over x plus 4, bless you. The x plus 4 cancels, and so it's just x. Okay, then my second fraction, what am I going to multiply the 2 by? X plus 4. That's what I'm missing. Okay, so that becomes 5x over x plus 2x plus 8. So 5x over what? 3x plus 8. Can't simplify that, so I'm good. Do we have questions on this? Okay. All right. So how we were doing the bottom when we had 2, now you just do that with the top also. Okay? So I've got x plus x over 3 over x minus 6. I'm still only looking at my denominators. So if I'm looking at just my denominators, 3 and 6, what's my LCD? 6. If it helps you to write it over on the left so you can see it, then you can. Okay? This x doesn't have a denominator, right? So I'm just doing 6 times x, which is 6x. But when I do x over 3 times 6, that can simplify, right? What do I really need to be multiplying 3 by to get to 6? 2. This would be a 2. So this is just a 2x. Okay. The bottom, 6 times x, is just 6x. The right fraction, those 6's cancel, and I have a minus x. And then we just clean it up. 6x plus 2x is 8x. 6x minus x is 5x. Can I simplify that? Because x's can. It's only one term. Okay? So if I had 8x plus a number and 5x plus a number, then no, I couldn't simplify that. But if I only have an 8x and 5x, think about 8x squared over 5x. Could I simplify that? Yes, you know you could subtract 2 and 1 and give me just a 1x. So same thing here, and that just leaves me with 8 bits. Okay? Here, next problem, what's my LCD? Just x. So if I took 2 over x and multiplied it by x, what am I left with? 2. Right? Because that would cancel. If I need to write it, I can. That would cancel. But here, I don't have a fraction, so it's a negative 4x. Okay, my denominator, those x's cancel, and I just have a 2. Plus what? Okay. The only thing I could try to do is take out a 2 in the numerator, but I couldn't take out anything in my denominator, so that would just be a useless step. If you do it, that's okay. I'm not going to count off. That would give me 1 minus 2x over 2 plus 3x. Okay. Technically, this is not in standard form, but if you left it like this, I think I'll be really happy. Because you got it all the way down to the answer. It's just not in the right form. Okay? So if you did put it in standard form, you'd have negative 4x plus 2 over 3x plus 2. All you're doing is rearranging. Because this is a whole binomial. Once you throw in a second term, you have to see it as a whole, not two separate things. Okay. Are we okay? Alright, I've got 3x squared, 3y squared, x squared y, xy squared. When you have all of that, do number and then variable, variable. Okay? So I've got a 3 and a 3. What's that going to be? A 3. I have an x squared, and an x. Which one am I going to choose? X squared. I have a y squared, a y, and a y squared. Y squared. Alright, so I'm going to multiply that by 3x squared, y squared. Alright, this first fraction in my numerator. What is it missing? Y squared. So 1 times y squared is y squared. Minus, I know I'm going to have a 25, because that's my numerator. 3y squared, what am I missing? X squared. So I multiply that by the 25, 25x squared. Yes, y'all follow me? Okay. Okay, x squared y. Look at your LCD. What am I missing? The 3 and the y squared. I have one y. I need one more, right? To get y squared. So I'm going to take that 1 and I multiply it by 3. So it's going to be 3y. Alright? X, y squared. What am I missing? So I take that 5 and I'm going to multiply it by 3x. So y squared minus 25x squared. And then 3y plus 15x. Okay. Because I have x and y's, y'all's instinct is to not simplify it. You can simplify this. This is the difference of two squares. I got a y and a y. Square root of 25 is what? So 5x and 5x. Now my bottom, what could I do? Take out a 3. That leaves me with y plus 5x. Now what can I do? They're partying up in there, unlike us. Y minus 5x over 3. Okay? I want you to try to do this one on your own. All the way through. you know what the LCD is? Did y'all at least get that? Okay, so the 6, what am I multiplying that by? X. And then plus 1, what am I multiplying that by? Okay, we got that? Alright. The 3, what am I multiplying that by? Minus 2x. We good with that? Alright, then we just got to clean it up. So that gives me 7x minus 5. This is 3x minus 15 minus 2x. So 3x minus 2x gives me 3 minus 2. Gives me 1. Who got it right? Okay. So what are we missing? What part did we mess up on?
I just got assigned.
Okay. That's good. Just a sign.
Process.
What about anyone else? Do we have questions? Okay. I'm going to pass out. You've got part 1 and part 2, and we're going to omit. So I'm going to just pass them out, and then we'll figure out what we're omitting. Okay?